Hi and welcome back. So in this lesson we're going to talk about section 10.3, which the topics are double angle identities and lowering power formulas. And today we have with us Midnight down here, Ariana, and Little Franklin. And we're all here to talk about section 10.3. Now before we dive into the material for 10.3, I want to start with a bit of a warm-up, which is one of the practice problems from section 10.2. And so in section 10.2, we had one of the practice problems is number 51. Now, if you're saying to yourself, "Whoa, Diane, I didn't know we still had practice problems," there are still practice problems, and they are listed on the homework page on the website. So we have our remote assignment page and remote class page, and then we have a separate homework page which still lists the practice problems, even though I don't mention them at the end of every lecture. Okay, so section 10.2, number 51, the problem asks us to verify the identity, and the identity that we're given is sine of 2x is equal to 2 times the sine of x times cosine x. All right, now anytime that we want to verify an identity, remember that what we're thinking is that it is not clear if this equation is actually true or not. So the way that we check to make sure that it is true is that we split up the two sides. So we have a left-hand side, which in this case is sine of 2x, and then we have the right-hand side, which is 2 times sine x times cosine x. And typically what we want to do is we want to choose the more complicated side and try and simplify it to get the other side. Now, in this case, both sides are complicated for different reasons. On the right-hand side, we have a couple of trig functions, but on the left-hand side, we have something fancier inside the parentheses. So I'm going to make the suggestion that we work with the left-hand side. And part of the reason for that is, to be fair, this problem comes out of section 10.2, and that's a section where we learned about the addition and subtractions or sum and difference identities for sine and cosine. So what I want to think about here is with this left-hand side, I can actually use a sum or a difference identity on this. So think about this. 2x is really the same as x plus x. So I can write sine of x plus x. Now, if I want to now use our sum or difference identity, probably the one I'm going to use is the sine identity, where I'm adding two things together. So I'm going to write down what that identity is, and that identity is the sine of a plus b is equal to the sine of a times cosine of b plus cosine of a times sine of b. Now, you might be asking, wow, do I need to have this identity memorized? Well, if you can, that's great, but there's 4 of them, and they're all real similar, so I don't think you need to have them memorized, but you want to be aware that they exist and be able to say, oh, this is the identity I want to use, let me look up the formula to make sure that I have it written down right. Okay, so back over here, we have sine of x plus x. So in this case, the a from our sine of a plus b is being played by x, and so is b. So when I write down this expression, then what I have is sine of x times cosine of x plus cosine of x times sine of x. Since both my a and my b are both x, they're all the same. And now when I look at this, what I notice is I have sine of x times cosine of x, and both of these terms are actually the same, they're just in a different order. So what I really have here is 2 of these sine of x times cosine of x terms. And so this tells me that my left-hand side is equal to my right-hand side of my equation. Okay, so we have just verified this identity. And what I want to point out about this, she's kind of upset about this. Here, hold that. What I want to point out about this is that this identity, sine of 2x is equal to 2 times the sine of x times the cosine of x, is our first example of a double angle identity because we're doubling the angle inside the parentheses. Okay. The second thing that I want to point out about this identity is that the warning is that you might be tempted to take that 2 inside the parentheses and bring it out in front. Because that's what you do when you have multiplication. You can bring stuff out front. But the warning is that sine of 2x is not equal to 2 times the sine of x. So you ask, what is sine of 2x equal to? Well, sine of 2x is equal to this guy up here. And you might be upset about that, like Ariana is, that you cannot just bring that 2 out in front. But that's why we have this whole trig class. If we could just take the number inside and pull it out front and that would give you an answer, we wouldn't need this class. Okay, so we just saw that sine of 2x is equal to 2 times the sine of x times the cosine of x. The main thing I want you to get from that is that we are not allowed to pull that 2 out in front. Okay, so whenever you have a double angle, 2 times something, you can replace that with some formula that no longer has double angles. Now, why is that important? It's not really clear. What I want to spend the rest of our time on in this first part of our lecture is I want to talk about the lowering power formulas. Now, again, this will be another semester away, but when you take Calc 2, in Calculus 2, you're going to learn about something called integration. And when you are integrating things, you're going to see this long stretched out S symbol, and you might have a function in the middle. So for example, you might have something like, and this we would read this as the integral of sine squared x dx. For this class, you do not need to worry about what this means, but the point is, in Calc 2, you're going to spend a lot of time working and talking about how to evaluate expressions like this. Now, it turns out that when you have an integral like this, and you have a sine or a cosine function that's raised to a power, especially an even power like 2 or 4 or 6, then this integral is really hard to evaluate. And so in Calc 2, you spend time learning some techniques to integrate things, and what we do in Calc 2 is we replace this sine squared of x by an expression that has a lower power. So we're going to talk about these lowering power formulas, and what you want to do is kind of tuck them away in a notebook somewhere or in your brain, and then when you hit Calc 2, you can say, oh yeah, I saw those once before, and now I'm going to use them. So we're going to talk about how to get these formulas. Well, it also turns out that integral of cosine squared x dx is also really hard to evaluate. Okay, so we are going to derive the lowering power formulas for cosine squared x and sine squared x. All right, so we're going to start here. We're going to start by using the sum identity for cosine of a plus b formula, to write a formula for cosine of 2x. Okay, so at this point, what you probably want to do is ask yourself, do I know the formula for cosine of a plus b? Do I know that some identity for cosine? If the answer is no, you should pause the video, go back in your notes, and find that formula for cosine of a plus b. Okay. I'm going to go ahead and write it down. So cosine of a plus b is equal to cosine of a times cosine of b minus sine of a times sine of b. And we want to use that formula to write a formula for cosine of 2x. So how are these going to connect? Well, I'm going to rewrite 2x as x plus x. And so when I do that, then this first x is playing the role of a, and the second x is playing the role of b. So we have cosine of a, which in this case will be cosine of x, times cosine of b, well that's also cosine of x, minus sine of a, so that will be minus sine of x, times sine of b, well that will also be sine of x. Okay, so I've written all this stuff down, and I'm going to simplify things a little bit. I have cosine of x times cosine of x, that's cosine squared of x, minus sine of x times sine of x is sine squared x. So what we've just written down is that cosine of 2x is equal to cosine squared x minus sine squared x. Okay. Take a second and look at this identity. This is a second double angle identity because we have a 2 times the angle inside the parentheses. If I cover up this left-hand side and I kind of squint at the right side, this right side almost looks like the most awesome trig identity in the entire world, which, as you know, the most awesome trig identity in the entire world is cosine squared x plus sine squared x equals 1. Okay. That difference of, instead of having a plus sign in the middle, we have a minus sign. With the plus sign, cosine squared plus sine squared equals 1, but if you switch out that plus sign and put a minus sign in here, cosine squared x minus sine squared x equals cosine of 2x. Big difference by just changing a plus to a minus. Okay, that's not the end of our story. That's just a piece of the story. Okay, so remember our goal is we want to come up with a formula for the lowering power formulas for sine and cosine. We're not there yet, but we do need this identity to get there. Our next step in this derivation is that we are going to turn the right-hand side of this equation right here, of this formula, entirely into cosines. So we're going to turn the right-hand side in terms of only cosine. Okay, so what do we have here? We have cosine of 2x is equal to cosine squared x minus sine squared x. And what do I mean by turning that right-hand side in terms of cosine? Well, I know that Pythagorean identity that says that cosine squared x plus sine squared x equals 1, the best identity ever. And if I solve this identity for sine squared x, well, how do I do that? Well, I have to subtract cosine squared from both sides. And so when I do that, I get sine squared x equals 1 minus cosine squared x. Okay? I'm going to use that over here, and instead of having a sine squared x up here, I'm going to replace sine squared with 1 minus cosine squared. Okay, so we now have cosine of 2x is equal to cosine squared x minus the quantity 1 minus cosine squared x. Okay. Everything on the right side is entirely in terms of cosines. I'm going to clean things up. The way I can clean things up is distribute this negative, so I have minus 1 and then plus cosine squared x. And all of that is still equal to cosine of 2x. Now I have a cosine squared x and another one, so I have a total of 2 cosine squared x and then a minus 1. So we have cosine of 2x is equal to 2 cosine squared x minus 1. Awesome. Okay, by the way, here's another double angle identity. Cosine of twice an angle, this is a double angle identity. Okay, we've got that guy. That's another piece of our puzzle. A third piece of our puzzle is we are going to take this original expression of cosine of 2x is equal to cosine squared x minus sine squared x, and instead this time we are going to turn the right hand side entirely in terms of the sine function. Over there we turned the right hand side entirely in terms of cosine. Now we're going to do this in terms of sine. Okay, so I'm going to use that Pythagorean identity, the best one ever, cosine squared x plus sine squared x, but this time I'm going to solve for cosine squared x, which means that I'm going to subtract the sine squared from both sides, and what I'll get is cosine squared x is equal to 1 minus sine squared x. Okay? That means that I'm going to take cosine squared x equals 1 minus sine squared x, and up in my original formula, I'm going to replace cosine squared x with 1 minus sine squared x. All right? So let's see, that's going to give us cosine of 2x is equal to 1 minus, oh, wait, hold on. So cosine squared x is 1 minus sine squared x. So we have 1 minus sine squared x, and then minus our other sine squared x. And that gives me cosine of 2x is equal to 1 minus 2 times sine squared x. Okay, so think about what we just did. You might be like, why did we do all of that? Well, that gives us 3 double angle identities. All of these are double angle identities for cosine, and they are cosine of 2x equals cosine squared x minus sine squared x. Cosine of 2x is equal to 2 times cosine squared x minus 1, and cosine of 2x is equal to 1 minus 2 times sine squared x. So these are 3 double angle identities for cosine. Wahoo! Okay, to be honest with you, you will probably not be using these 3 identities very much at all. In fact, I can't really think of the last time that I actually used these identities, the ones that are listed here. But we needed these identities. We need these identities because they are going to give us the lowering power identities, and those are the ones that you do need when you take Calc 2. For those of you that aren't going to take calculus, sorry, you might not use these identities at all. But for those of you that take Calc 2, you want to know these lowering power identities. Okay, so here's the last part. Here's the part where we actually get these lowering power identities. We are going to take, well, we'll start here with the middle one. Cosine of 2x equals 2 cosine squared x minus 1. So cosine of 2x is equal to 2 times cosine squared x minus 1. And we are going to solve this equation for cosine squared x. Okay? So the very first thing that I want to do here to solve for cosine squared x is I'm going to add 1 to both sides. And so I have 1 plus cosine of 2x equals 2 cosine squared x. And then I want to divide both sides by 2. And so what that leaves me with, and I'm going to flip the equation, the left and the right sides. What that leaves me with is cosine squared x is equal to 1 plus cosine of 2x all divided by 2. And this identity is one of the identities that you do want to know. This is one of our lowering power identities or lowering power formulas. Cosine squared x is equal to 1 plus cosine of 2x all over 2. All right. We can do something similar with our last equation down here. Cosine of 2x equals 1 minus 2 times sine squared x. So we have cosine of 2x is equal to 1 minus 2 times sine squared x. And we can solve this equation for sine squared x. Okay, well, in order to do this, to make it kind of look nice in the end, I'm going to start by adding 2 sine squared x to both sides. And so I have 2 sine squared x plus cosine of 2x is equal to 1. And then I'm going to subtract cosine of 2x from both sides. And so I have 2 times sine squared x is equal to 1 minus cosine of 2x. And then I'm going to divide both sides by 2. And what that leaves me with is sine squared x is equal to 1 minus cosine of 2x divided by 2. And so so we have one lowering power formula, one for cosine squared, and one for sine squared. And what you'll see is that left side sure looks prettier and nicer, but it's got a power. And it turns out when you want to integrate stuff, when you're in Calc 2 and you do this thing called integration, that having those powers on the trig functions makes stuff really, really hard. And it turns out that this expression on the right side, 1 plus cosine of 2x over 2, is easier than working with cosine squared. And 1 minus cosine of 2x over 2 is easier than dealing with sine squared. Okay, in part 2 of this video, we are going to be talking about how to actually lower powers when we have things like sine to the 4th, for example. All right, see you in a bit.